All right, in chapter 5, we look at aggregating, which is just a fancy word for putting together different things. So aggregating and analyzing performance improvement data. So we start with data collection. Where does the data come from? Well, we get it from places like patient health records, organization-wide incident reports, employee performance evaluations, staff competency reports, patient surveys, and things like that. So data is used to establish a baseline, which provides a point of reference when we're making comparisons. We have to have something to compare things to, so that's called the baseline. And the baseline is established by averaging all the data collected on a specific area of interest. So that's how you get things like averages. So when internal benchmarking is done, the organization compares new findings to the established baseline to determine success or failure. So that's internal benchmarking. In external benchmarking, we compare our organization's performance to other organizations that are performing the same types of service. So those are external comparisons. The type of benchmarking that we select depends on the type of comparison that we're making. So to evaluate the effectiveness of a new system within an organization, internal benchmarking would be appropriate. And to evaluate how the organization is performing compared to other organizations, such as the number of nosocomial infections for cardiac patients, for example, external benchmarking would be the appropriate measure. So collection tools. How do we get the data? We get it through incident reports, safety and infection surveillance records, employee performance appraisals, staff competency examinations, restraint use logs, adverse drug reaction reports, surveys again, diagnosis and procedure indices, case abstracts, peer review reports. We have all sorts of different available areas to collect our data from. So how much data do we need? How much do we need to collect? Sometimes the amount of data is small and we can look at all of it, all the data that we have in the PI process. Sometimes we're looking at a process that might take place thousands of times in a study if we're looking at things like blood pressures or checking in patients, that sort of thing. So we need to select a representative sample. So what size sample do we need? If we're looking at fewer than 30 cases, we're going to use 100% of those, and we call our sample a population. So it's not necessarily people, it's just our sample size. If we have 30 to 150 cases in our data, we want to sample 30 cases. If we have 151 to 595 cases, we want to figure what 20% is and sample that. And there's a typo there, for more than 595 cases, we're going to sample 120 cases. So no matter whether we have 10,000, we're still going to sample 120. So the simplest collection tool that we can use to gather this information is a check sheet. The data on the check sheet helps us to establish patterns. And so these facts assist our team in translating opinions into facts. So remember, through the whole process, what we've done is we have identified what we feel is an opportunity for improvement. But again, that's our opinion. So what we need to do is to collect the data that turns that opinion into a fact. So the check sheet is going to be created with who will collect the data, what data is going to be collected, where the data will be collected, and the time frame over which we're going to do that collection. And we can collect different types of data to use for different things. There are 4 basic categories, and each type of data is best communicated and reported in specific formats. So for nominal data, which is also called categorical data, this would be described as values assigned to name-specific categories. And the chart type used to display nominal data would be bar graphs or pie charts. Ordinal data ordinal are things that go in order, so think of it that way, or ranked data. These would be described as expression of the comparison of information by assigning a value to each by ranking it. Think of a Likert scale where it's rate how well you liked this on a scale of 1 to 10. So something like a Likert scale displays ordinal data. We can also use bar graphs and pie charts for ordinal data. Discrete data is also called count data. So these are whole numbers, number of children, number of cars, number of incidents, so things with an actual whole number count. The best way to display this type of data is in a bar graph. Continuous data are numbers with an infinite number of possibilities. So these are numbers that have decimal points. Think of it that way, because we could have any number. They're not just nice round numbers. The best way to share this kind of data is in a histogram or a line chart. There are a couple of terms that we should be familiar with when we're talking about data. They're absolute frequency and relative frequency. So absolute frequency refers to the number of times a core value occurs in the data set. So if you take a look at table 5.1 in chapter 5, you'll note that in the respiration rate recorded column, the value 25 per minute, that occurs 3 times. So the absolute value there is 3. And then the relative frequency is the percentage of the time that value appears. So looking at that same table 5.1 in chapter 5, we see that again that value 25 per minute occurs 3 times out of a total of 7. So we divide 3 by 7 and come up with 42.9. So the relative frequency of 25 beats per minute, or 25 respirations per minute, is 42.9%. So how do we manage these data sets? Healthcare organizations today use one or a series of databases which are typically housed and grouped together within their electronic health record system. That's how they capture and store their information. These databases bring together information from the patient financial system, the patient management system, as well as the clinical system. So all of those databases are pulled together into the electronic health record. The PI team has to be careful to only use data that accurately reflect what they're investigating, and team members really have to all understand how the data was created. And so once that data set is chosen, the team has to be sure that they can identify and extract it, and then the reporting can begin. So the process of asking this database or these databases to provide us with a data set is called querying. So a query is asking something. So statistical analysis. This whole course is going to discuss statistical analysis, but you've had a whole class in statistics. So we're going to do brief touches on that, but not delve into great detail. But I do want to go over some of the statistical analysis terms that are used in your book. The first one is the mean. The definition of mean is arithmetic average of a distribution of numerical values. So how is the mean calculated? We add all the values together, then divide by the number of values observed. So for example, let's say our values are 1, 2, 3, 4, and 5. We add those together for a total of 15. We have 5 values, so we take 15 divided by 5, which gives us 3. So the mean in that series of numbers is 3. The median, by definition, is the middle value when all observed values are placed in ascending or descending order. So there's no real calculation needed as long as you have an uneven number of terms. So let's look at this example. Let's go with those values again. 1, 2, 3, 4, 5. It doesn't matter if we list them as 1 to 5 or 5 to 1. So when placed in descending or ascending order, the middle one is 3. So in this case, the median is 3. So that's always nice and easy when you have an uneven number. But when you have an even number, so let's say this time we have values that are 1, 2, 3, 4, 5, and 6. the mean would fall between 3 and 4. Those are the two in the middle. So we do have to do some sort of calculation in this case. So what we do is we add the two middle numbers together, divide that by 2, and we reach our mean. So we take, in this case, 3 plus 4 is 7, and we divide by 2 equals 3.5. So in the range of values 1, 2, 3, 4, 5, and 6, the mean is 3.5. Now, skewing is something that can take place, especially when we're looking at the median. So skewing occurs when we have a lot of really high or really low numbers, and they're going to distort the mean. So if you had 20 instances of 1, and then 2 2s, 2 3s, 2 4s, and 2 5s, when we list all of those, you can see that when we go toward the middle, we're actually going to be looking at a lower number just because we have so many that occur in that low range. So that is skewing. So when we pick the middle value, we're going to have lots of low numbers that throw that off. So skewing. And a standard deviation, you should know what this is when you read it or hear it, but for the purpose of this class, you're not going to be asked to be calculating standard deviations. It's a pretty complex analysis technique. You have to do all kinds of calculation, and basically what you're doing is determining the margin of error. All right, so once we have our data and we want to be able to display it, because visualizing it can help us to see things that we don't see when we just read the list of values. So examples of data display tools are bar graphs, histograms, Pareto charts, pie charts, pivot tables, line charts, and control charts. All the data that we choose to display should be done simply and accurately. We have to be sure to report all data, no matter what the implications, whether it supports what we want or whether it does not support what we want. We still have to report our findings correctly. So a bar graph. Description: uses bars to visualize information. Its use is to display discrete categories. And the layout: the categories are placed on the horizontal or the x-axis. So that's the line across the bottom. The number of frequency values are placed on the vertical or the y-axis. So that's going to run up the side. We could use a histogram, which is a bar graph that displays data proportionally. What do we use it for? To identify problems or changes in a system or process. What does a histogram layout look like? A histogram keeps the data in the order it was obtained. So intervals of continuous data are placed on the horizontal or x-axis, and the absolute frequency of occurrence is placed on the vertical or y-axis, which is always going to begin at 0. We could use a Pareto chart, and that is a kind of bar graph that uses data to determine properties. What's its use? It helps the team to focus on problems and their causes, and to demonstrate which are the most responsible for the problem. So there might be multiple causes, but which one is most responsible? What does the layout look like? This one is a little more complicated. It's a combination of a bar graph and a line graph. Then we have the pie chart. So the pie chart is a circle divided into sort of slices that are proportional to each component's percentage of that pie as a whole. And it's used to visualize percentage proportionally. What's the layout look like? Well, it's a circular, air quotes here, pie with slices that indicate the percentage of the whole that's being represented. A pivot table. A pivot table is something that's created in Microsoft Excel. So anytime you hear pivot table, you know that is the tool that was used to create it. It's used to summarize data according to categories, and the layout would be an Excel spreadsheet. Then we have a line chart. So we see these a lot. They're simple plotted charts of data. They're used to show the progress of a process over time, And we can look for peaks and valleys to indicate possible problems with the process. So you see these things a lot when they show stock market or blood pressures or respiration rates. You see them go up and then they might tick down, they might level off. So uh, hills, valleys, and leveling mean different things in the process. So the layout, the time frame is placed on the horizontal or x-axis, and the number of occurrences or the actual measure of a parameter is placed on the vertical or y-axis. And last we have the control chart. Now the control chart is a little more complex. It's a chart that shows a visual representation including the standard deviation. So what it does is it shows the upper limit and the lower limit. It's used to measure a key process over time, and it focuses attention on any variation in the process. So the control chart is going to become the standard that we use, that the team can use to compare future data for the process. So it can become the benchmark. And the layout, again, it shows that upper and lower limits of the information. So that is aggregating and analyzing performance improvement data.